What's good, everybody? It's your boy Bo Maths coming back to you with another spicy math video. Today we're going to be doing some practice. I've got some nice juicy problems for you here. These ones in particular are a little challenging, but I think you can do it. If you're not sure, we are practicing converting decimals to fractions. That's what we learned how to do in the last video. We looked at some of the theory behind it, and yeah, we're just going to get comfortable with the concept. So once you've tried all of them, you can proceed watching the video, because we're going to get into it. Alright, so to get started, we've got a pretty standard type of problem: convert the following decimals into fractions. So let's go ahead and do it. So we'll start with the first one, 0.12. So the method we saw to convert decimals into fractions is we basically took kind of this decimal part here, the 12, and we are going to put it in the numerator of our fraction. And then we wanted to put some power of 10 down here that would basically move the decimal behind the 12 up to where it is in the point 12, right? So it was shifted over two places, so that means we're going to need a power of 10 with two zeros. So 12 over 100, which is 12 divided by 100, will move the decimal right here over two places, which will give us 0.12. So this is a fraction that represents 0.12. However, whenever we're dealing with fractions, we always want to look at the most simplified fraction possible. So how can we simplify 12 out of 100? Well, they both can be divided by 4. So if we divide them by 4, 12 divided by 4 is 3, 100 divided by 4 is 25. We're going to get 3 out of 25 as our final, most simplified fraction that is equivalent to 0.12. Alright, so that's good. Let's go on to the next one, a little bit of a longer decimal to deal with, 0.108. So just like normal, we're going to put our decimal part up top here, so we have the 108. And because this decimal was moved over 3 places by the looks of it, we're going to want to be dividing by 1,000 because that has 3 zeros there. So now that we have this, we can re-express this fraction in simpler terms. So because these are a little bit bigger, we could figure out what their greatest common factor is to know kind of the optimal way to simplify them. So let's go ahead and do that. So we get 108's prime factorization is 2 times 2 times 3 times 3 times 3. And then we're going to look at 1,000's prime factorization. So that's going to be 2 times 2 times 2 times 5 times 5 times 5. To find their greatest common factor, we find all of their common prime factors, which in this case is just 2 times 2. So both of these can be divided at most by 4 because that's their greatest common factor. So 108 divided by 4 will be 27. And 1,000 divided by 4 will be 250. And since we divided by their greatest common factor, this is going to be the most simplified fraction that gives us the decimal of 0.108. Alright, so let's go to the next one, 0.02. So here we want to write out the number up top. We could write 02, but 0 in front of a number doesn't really change anything, so we can just write 2. And how many times was the decimal moved over? It was moved over 2 times, so this is going to be out of 100. So we have 2 100ths, but that can be simplified. These are both even, so they both can be divided by 2, the numerator and the denominator, simplifying down to 1 out of 50. So 1/50th is the same as 0.02. Alright, next up we have 0.019. So kind of like with the 0.02, there's a 0 in front here, but the 0.19 is just going to be the same as 19 on the top, and our decimal's been moved over 3 times, so it's going to be 19 out of 1,000. Now, in terms of figuring out if this can be simplified or not, 19 is a prime number, you might recall. It has no factors other than 1 in itself, and because of that, it's going to have no common factors with 1,000, because 1,000 is not a multiple of 19. So essentially, their greatest common factor is 1, they're co-prime with each other, so this is as simplified as it gets. So 0.019 is equal to 19 out of 1,000. And this very last one here, we've got a really long decimal, and then we got 6 zeros, and then a 1. Alright, so we're going to have 1 in our numerator. And how many times was this decimal moved over? 1, 2, 3, 4, 5, 6, 7. It was moved over 7 times, so that means we're going to be dividing by a power of 10 with 7 zeros, or 10 million. If that's too many zeros to write, we could also write this as 10 to the power of 7, right? Since that is equivalent to just a 1 with 7 zeros after it. So this 1 over 10 million, or 1 over 10 to the 7, is the fraction that gives us 0.00000001. Hopefully you're nice and comfortable with the method now, but if you want some more practice, just pick any decimal you want and try and convert it into a fraction. All right, let's move on to question 2. All right, so question 2 asks us to convert 0.75 into a fraction and simplify it, and then convert that simplified fraction back into a decimal. Well, this is nothing different than question 1 so far when we are converting 0.75 into a fraction and then simplifying it. That's just doing what question 1 was asking us to do. But then afterwards, we're going to want to put it back into a decimal. And since they're equal to each other, we should expect our answer to be 0.75 again. But we need to just kind of confirm this. And that's the point of this question, is to verify that, yeah, these fractions and decimals are equivalent. We can convert back and forth between them and always get the same thing. So we have 0.75, and to put it into a fraction, we're going to need 75 on top. 2 decimals have been slid over, so we're dividing it by 100. So we have 75 out of 100. Now we can find their greatest common factor to figure out how to optimally simplify this. So 75, you'll find, is 3 times 5 times 5 with its prime factorization, and 100's prime factorization is 2 times 2 times 5 times 5. So what is going to be the greatest common factor? It's this 5 times 5, or 25. So we can divide both 75 and 100 by 25. 75 divided by 25 is 3, 100 divided by 25 is 4. So we get the most simplified fraction for 0.75 is 3/4. So that's the first part done. Now we want to put it back into a decimal, so we're going to convert 3/4 into a decimal and see if we actually do get 0.75 or not. So if you recall it from the last lecture video, how do we convert a fraction back into a decimal? We do it with long division, noting that 3/4 is the same as 3 divided by 4. We can put them into a division scenario here. So how many times does 4 go into 3? It doesn't, right? It's too big. So we have to add in our decimals. So now we're thinking of this 3.0 as 30. How many times does 4 go into 30? It goes in 7 times, right? 7 times 4 is going to be 28. So then we'll subtract off this 28, and we will get 2. So now we have a 2 left over, but 4 can't go into 2, so we need to put another 0 after this 3. Again, it's always still 3 because this decimal here, we can add as many zeros as we want. So we bring down the 0. How many times does 4 go into 20? It goes in 5 times. So 5 times 4 is 20, subtract it off, no remainder, so we have converted it, and what do you know, we're back at 0.75. So we do see that we can convert from decimal to fraction and then back to decimal, and we get back to the same thing. All right, so let's move on to question 3. All right, so question 3 says, give an example of a decimal between 0 and 1 that's 9 digits long and whose simplified fraction will have a denominator of 10 to the 9th. Okay, so we're supposed to come up with a decimal that's 9 digits long, but we have to make sure that its simplified fraction has a denominator of 10 to the 9th. So what is 10 to the 9th? Well, that's just 1 with 9 zeros after it, right? Which is also a billion. All right, so that's a pretty big number. So we want a billion, or 10 to the 9th, to be the denominator of this fraction. And we need to basically get a decimal that when we put the numerator up here, it can't be simplified anymore, right? The simplified fraction has this as a denominator. So what does this mean? Well, basically, we just need to choose a numerator up here that's going to be co-prime with 10 to the 9th. The simplest choice is just going to be 1, right? Because 1 is always co-prime with 10 to the 9. You can try and choose other numbers, like 13, for example, would work, because 13 is co-prime with a billion. 7 would work, 11 would work, so you have options. But basically, we're just choosing some numerator that's co-prime with 10 to the 9. So when we convert this to a decimal, we're doing 1 divided by 10 to the 9. But if you recall the fast method to do division by powers of 10, we just basically pad our 1 with a bunch of zeros, and then we take the decimal after the 1, and we're going to slide it to the left 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, we have 8 zeros in front of the 1. So if we look at the decimal then, 0.1234567 and then put a 1, this is going to be equivalent to 1 over 10 to the 9. So we've essentially constructed a decimal here It's between 0 and 1. It's 9 digits long, right? 8 zeros and the 1, so that's 9 digits in total. And its simplified fraction had a denominator of 10 to the 9, right? Because the 1 up top was co-prime with 10 to the 9. It can't be simplified any further, so we have done question 3. And this would work for other numbers, like I said, for example, if we did this with a 7, because 7 is also co-prime to 10 to the 9, or to a billion, so we have options. So maybe you can try a couple other ideas and leave them in the comments. All right, so question 4, it's a little more challenging, but I think you can still do it, and I think it's a really interesting problem, so hold on to your hats. So suppose I have a 2-digit decimal between 0 and 1, and it's an even hundredths place. Okay, so it's a 2-digit decimal, so we have, and it's between 0 and 1, so we have a 0 point, and then we're going to have 2 digits here. And the hundredths place, well, this is the tenths place, the hundredths place is the second decimal spot. That needs to be even, so this needs to basically be a 0, a 2, a 4, a 6, or an 8. All right, so some examples are 0.12, 0.98, 0.04. So these all satisfy this property between 0 and 1. They're 2 digits long, and there's an even hundredths place. So what we want to do is we want to prove that when we convert this decimal into a fraction, its simplified form must have a denominator smaller than 100. So this is saying for any decimal of this form, right? There's a lot of decimals that satisfy this property. These are just a few of them. We want to show that when that decimal gets converted into a fraction, its denominator is going to be smaller than 100. So first of all, why 100? Well, in general, when we have a 2-decimal fraction, for example, 13, what we're going to do is we're going to take that, and since it's 2 decimal places, we're going to be dividing it by 100, because 100 has 2 zeros, right? So for these 2 decimal numbers, the way we're converting them to fractions tends to be putting them in a fraction with a denominator of 100. So that's why 100 is relevant here. But what this is claiming is that if it ends in an even number, that is going to be a simplifiable fraction. It can be simplified to something smaller than 100. So for example, the 0.12 we're given there, that's 12 out of 100. 12 and 100 are both divisible by 4, so if we divide them both by 4, we get 3 out of 25. So this is indeed a decimal that can be simplified to a fraction with a denominator smaller than 100. But that's just one example. How do we show that this is true for literally every single decimal satisfying that? We don't just want to systematically go through all the decimals and try and show it, because that would take us a very long time. So how can we show this generally? Well, the idea is that when we convert the fraction into a simplified form, the numerator is going to be an even number, right? And since it's an even number, that means it's going to be divisible by 2. So that means 2 is a factor of the numerator, and 2 is also a factor of 100, right? 100 is even, it's divisible by 2. So since 2 will guaranteed be a factor of both the numerator and the denominator, we will be able to simplify the fraction by dividing both the numerator and denominator by 2, right? So for example, if I look at 0.14, that's 14 out of 100. 14 and 100 are both even numbers, so they can both be divided by 2. 14 divided by 2 is 7, 100 divided by 2 is 50. So we get that this decimal here can be expressed as a fraction with a denominator smaller than 100 because the numerator was also going to be divisible by 2. Since this decimal has to have an even hundredths place, its last part is going to be even, which means the whole decimal, when we think of it in the numerator, is guaranteed to be an even number. So let's write all this out. All right, so this ended up being a lot of writing, but just to recap concisely, since the hundredths place in the decimal is even, when we look at the whole number version of the decimal in the numerator, we get an even number in the numerator, right? So in this case, the 0.14, the hundredth spot was even, so when we looked at the number in the numerator, which is the 14, we get an even number in the numerator. All right, so that's what this first part is saying. The second part is saying, since it's a 2-digit decimal we're converting into a fraction, the denominator will be a power of 10 with 2 zeros, namely 100. 100 is also even. So we're looking at a 2-digit number that we're converting. So that means 2 decimal slidings. So that means we're going to have to divide by a power of 10 with 2 zeros, right? Each 0 for each of the decimal slides. So that's going to be 100. And 100 is also even. So that's what the second part is saying. Now this last part, since the numerator and denominator are both even, they're both divisible by 2. And thus the fraction can be simplified to something with a denominator smaller than 100. So we established in this first part that the numerators has to be even. We established in the second part that the denominator is even. So since they're both even, they're both divisible by 2. So that's a common factor that we can divide both of them by to simplify the fraction. And since we can simplify the fraction guaranteed, this 100 has to get smaller, right? Simplifying the 100 means it's going to become a smaller number. So that means our denominator will be smaller than 100. So we're done the proof. And whenever you're done a proof in math, you put a little square at the bottom or a tombstone, which means you are putting the proof to rest. It's done with. All right, so I hope you found that interesting, and I encourage you to rewatch it and really think about it if you weren't quite sure about the explanation, and trying to come to a full understanding of it, because the next question is going to be very similar. Suppose I have a 3-digit decimal between 0 and 1. All right, so it's 0 point, and then we have 3 places here. When converted into a simplified fraction, it has a denominator smaller than 1,000. Viewing the 3 digits of the decimal as a whole number, what can we say about its prime factorization? So it says that when we convert this into a simplified fraction, which since this has 3 decimal places, originally it's going to be some number divided by 1,000, right? Because 1,000 has 3 zeros, so that means the decimal would have been moved over 3 places. But they're claiming that this number can be simplified into something smaller than 1,000. So the denominator can be simplified to something smaller than 1,000. So we're looking for some number in the numerator that will basically have this fraction be simplified. And then this number is basically what's going to go in our decimal spot. Okay, so basically we're looking for a 3-digit number that can be simplified when it's in the numerator of a fraction out of 1,000. So for the number and 1,000 to be simplified like this, that means they have to have a common factor, right? They have to have some sort of common factor that can allow them to be simplified. They're not co-prime with each other. So basically our number and 1,000 need a common factor, and the factor needs to be bigger than 1, right? Of course, every number has 1 as a common factor, but in order for them not to be co-prime, or in order for the numerator and denominator to simplify, they need a factor greater than 1 that we can take out of them, right? So they need a common factor greater than 1. Let's look at 1,000's factors. So we will look at the prime factorization of 1,000. So 1,000 is going to be 3 2's and 3 5's all multiplying together. That's its prime factorization. So basically our number then needs to have at least something from 1,000's prime factorization in order for it to be able to be simplified. So let's write that down. The number needs at least 1, 2, or a 5 in its prime factorization, because that means it's going to have a common factor with 1,000, right? So for example, what's a number that has a 2 or a 5 in its prime factorization? Let's go with 155. So if we look at 0.155, that can be written as 155 out of 1,000, right? But since 155 and 1,000 both have 5 as a common factor, that means that this can be simplified, right? 155 divided by 5 is 31, and 1,000 divided by 5 is 200. So this is a more simplified fraction with a denominator smaller than 1,000. So since we chose 3 digits here where the whole number version had a common factor with 1,000, which we determined had to be a 2 or a 5, in this case it's a 5, then that guaranteed that the simplified fraction had a denominator that was smaller than 1,000. So essentially we were just kind of going back to the last unit and using some things that we know about prime factorizations and what it means to actually have common factors. Namely, they have something common in their prime factorization, which was necessary to simplify this fraction. So I hope you found those problems interesting, and I hope you found them helpful. If you have any questions, feel free to let me know in the comments. But until next time, you have a good one, you stay groovy, and I'll see you in that next video.
maths.